Hello everyone, welcome to Center for Reliability Science and Technology of Changchun University. Let's come in and let me introduce the center facility and the capability. First of all, I would like to introduce that these are the 6 books that I've written, all relating to reliability. And there are 3 more is on the pipeline. And then the next thing is I would like to introduce that this center also had initiated a collaboration with the Singapore National University so that the student can come over here to do project in your undergraduate. We started in 2016. And on the other hand, our student from Changchun can go over to NUS to have the summer internship as well as a semester exchange. So this has been initiated from here. Then subsequently, I also initiated a joint degree program with the Singapore University of Technology and Design, where the student will study 9 months here in coursework and then 9 months in Singapore, SUTD, Singapore University of Technology and Design, and to do the project with the industry as well as with the faculty. Alright, the next thing I'd like to introduce is that this center is the only center in Asia where we have signed an MOU to be a business partner with Infineon because of our reliability work. Okay, this is one of the great milestones that we have achieved. Alright, so the next thing is that this center basically consists of me as a director who are founding this center in 2015 from nothing, and I will introduce this center more later on. One admin assistant and there are a few group leaders. My international advisor is my good friend, Professor Michael Pat. He's a director of the CReST, which is also, in fact, is the world #1 reliability center in the USA. Alright, so let me then introduce some of the technical work that I've done with the industry. Alright, so let's start from here. Now, this one work that I've done with LightOn, we're basically working on the reliability of a power package. Then this one here is working with another company, it's an MBI, and working on the LED driver to look at the reliability of an LED driver as well as the electromagnetic interference from the circuit design. Then the next one is on the LED, high power LED, where we actually working on the to look at the different degradation mechanism that happen in the high power LED, in particular on the outdoor performance. Okay, where there's moisture and temperature and how the encapsulation got cracked because of all these environmental conditions. So the work actually we are not working with any company, but we do purchase the product from the market, such as Osram and other brands, and then we perform it to study the physics of degradation under the environmental condition. Now, then we also work on this oximeter because the current market oximeter, they have a limitation in terms of able to detect lower blood oxygen level. And we identify the cause and then we actually modify this so that we can actually able to measure and also produce accurately the blood oxygen level even when people are suffering at a low oxygen level. Alright, so the next one, so that by the way, the oximeter really is working with Changchun Memorial Hospital. So this is the hospital work. Now this one here is actually working on the wire bonding. I mean, we all know that the chip have a wire bonding, and usually after the wire bonding, in order to determine the reliability of a wire bonding, we need to do a pull test and also subjected to temp cycle. Now, but the thing is that in general, we have to do the temp cycle and then we have to decap it and do the wire pull, which is very troublesome and very time consuming. What I've done with the company is that I can actually determine the wire strength without opening. and using electrical method. So this is the theory that I have developed and has been verified, so that I'm able to know how the wire strength, the bonding wire strength degrade under time cycle continuously without decapsulation. So the advantage is that we can know exactly when the wire, the bonding wire start to degrade. And this is very helpful, and because it's done in situ, so actually it can be very fast. Then I also work on the lithium-ion battery, where there are not many people in the world are working on the lithium-ion battery reliability. Many are working on the SOC or the SOH, and by working on the lithium-ion battery reliability as well as the battery pack reliability. So what I've done is that I've developed a model based on electrochemistry. So with the electrochemistry inside the battery, I derive a series of equations, which then I convert this equation into electronic components. So that now I can use the electronic circuit to represent the battery, and not only that, each component will represent different part of the component inside the battery, such as some component represent the anode, some component represent cathode, and so on. So by looking at how each component degrade, I will know that without opening the battery, I will know which part will degrade faster without opening, and therefore I can do an in situ degradation study of the battery, and I also can help to identify which other components are weaker, and therefore you can do a reliable design for the lithium-ion battery. Now, I also work on the printed circuit board reliability. This is an example that I work on. One of the examples is on the flyback converter. This is a switching mode power supply. And basically, is to look at how a PCB layout should be for a switching mode power supply so that it can last long. And especially because being a switching mode power supply, there are some components actually are very high power. It can display a lot of heat. So how exactly you should lay it out so that each component will have sufficient room for dissipating the power, and how do you choose the components so that the heat dissipation can be efficient, so that as a whole, the entire board, the temperature of the entire board will not be high, and therefore you can actually last longer. Alright, so another work is done with the Denmark company, Vestas, which is working on the wind turbine. Basically, this work is actually to look at how should we timely maintain the wind turbine, and so that we know we can make sure that this wind turbine can last at least 20 years. That's the minimum. All right. So I developed this predictive maintenance strategy so that we can ensure that at what time we should maintain this wind turbine, and at different time what are the components that we need to replace. So in this way, that they do not need to store a lot of components in their inventory, which is costly. So in fact, when I did this work, at the end of the day, their inventory room actually cut to 1/3, which saved them tremendous a lot of money. And also because they know exactly when to maintain, instead of wait until when there's a sign to signal that there's some problem. So this wind turbine can continuously operate, and at the same time can extend their time. So this actually came up, developed this strategy, and Vestas actually came up with a patent and to ensure that their wind turbine is better. All right, so the next work I've done is on the aircraft. Now this is an F-16 aircraft that I did with the Singapore Air Force. What happened is that when the flight go up, they're supposed to lift up the wheel to go into the plane, but somehow there's a problem. They cannot lift up. Okay, so I studied this root cause, and turned out that the root cause is really because of the wire that's connecting from the inside of the plane to the wheel to control it up and down. And so to make the story short, basically it is because of frequent up and down, and the wire wasn't tight enough, so some wire was hanging, and during the up and down, the wire are being rubbed, being cut by the metal piece. In the end, this is some open circuit. Now I'm currently doing another work looking at the maintenance of this centrifugal compressor, which is a very big compressor, and for this oil and gas industry. So this compressor is to convert the air into liquid oxygen, and so this product is very reliable, but they still want to hope that we can develop a method so that even before it is being degraded, that this we can actually know that it's going to be degraded, and therefore do a maintenance before any signal, any sign come up, so that we can predict when to maintain, so that the interruption to the operation is minimized. Now, the next thing I do is on this dialysis system, which is working with again the same Changchun Memorial Hospital, and this one here is basically is again to develop a very optimal maintenance strategy to see when should you maintain the dialysis, because the dialysis system it will be very dangerous if the system fails during the dialysis process. And so we can ensure that through our strategy, first of all, we ensure that the operation will be fine. Secondly, we know when to timely maintain the system. And so we come up with the maintenance schedules for this dialysis system. So at the end of the day, we help them to save about 10 million maintenance fee for their small operation room, and also that the availability is increased from 99.9% to 99.9999%, meaning that they never fail. Alright, so these are the work that I've done with the companies. Alright, now academic wise, I also have done some work in preparing for the industry need. Okay, one of the first things that I do will be on this work here, which is on this identification of the electromagnetic hotspot. So what we have done is that we have developed a method so that before an IC is made, and we can actually compute the electromagnetic hotspot, where will be the electromagnetic hotspot will be before even chip is fabricated. So this will be very good, because then we don't need to waste money in fabrication and then do the measurement and identify the problem. So we can do it by just giving us a GDS file, and we are able to build the IC in 3D format in a computer, and from there we can calculate the different where is the hotspot is. Not only we can calculate where the hotspot is, we also can calculate which are the components inside the integrated circuit is causing the hotspot. So once it's known, then the designer can actually do a proper design to elevate this problem, and therefore when they finally tape out, then the chip will be very good without wasting money and also shorten the time. Alright, so another work that I've done is that we are looking at a gallium nitride HEMS powered amplifier. Now this amplifier was supposed to be used for the 5G. It's a high power, and it's turned out that it doesn't work too long. There's some reliability issue. Now instead of trying to figure out the design or whatever, so what I did in working with another professor is to find out what is the root cause. So through the very detailed analysis, which came up in the paper on the IEEE transition of industrial electronics, and we actually discovered a new failure mechanism, which is very interesting. And this new failure mechanism is really because of the magnetic field coupling together with eddy current. So the magnetic field coupling through one of the transistor in the intermediate stage, and this magnetic field will induce the eddy current onto the plate, whereby it increase the current, increase the heat so much that it's actually melted the metal on top. And this is very surprising. In fact, the temperature is so high that even the underlying gallium nitride will decompose, and the gallium is coming up from the bottom to the top, where we can actually observe it in the SEM. So this is a very new failure mechanism, and we actually also do a simulation on the eddy current to see how it failed. All right. So I would like also to mention that interconnect is one of the main problems for for IC, and so copper interconnect is already running out of steam because of the high current density of electron migration and the heat. So what I've done is that I actually developed a new material, new interconnect material, where I put the metal, graphene, and metal. In other words, graphene is in between the copper. I developed a method to insert the graphene inside the copper. So by so doing, now most of the current will be carried by the graphene, because graphene is better conductivity than copper, and also is a very good heat dissipator. So as a result, the electron migration improves. Now the method that we use is that we discover a new method of how to put the graphene into the copper, and this paper is submitted to the Advanced Material Interface and becoming the cover page. And this method is so simple, is that it just simply immerse the copper first layer onto the solution of the copper sulfide electrolyte solution, and within a few minutes you can form a graphene on top of it, followed by the deposition of the copper. So this is work that actually have interested TSMC and to explore further. Alright, so then there will be other work that we have done, and so this work here basically is working with another company whereby these components are supposed to put in automotive. Now, being a high power devices, the current is high, so when there is a misalignment of the solder preform, so this solder preform will generate the high thermal resistance. This thermal resistance together with the high heat generation can cause the solder to melt and short circuit the anode and cathode. So what they have done previously with this company is that they're using an X-ray to screen it, so that anything when the solder preform are misaligned, that they can not stop shipping to a customer. But this, it will be very time consuming. So what I've done with the company is to develop an electrical method whereby without looking at the X-ray, they were able to know whether the preform, whether the solder has been misaligned or whether there's a contamination in the solder. So with this, so initially when they do the power cycle test, the reliability drops very significantly. But after the screening, so we actually able to do it, we're able to get a good device where the reliability only decreased slightly. And this can be done, the screening can be done in the order of 1 or 2 milliseconds. And that tremendously helped them to screen and to ensure that the customer are receiving the good part. Now, another work that I've done is for the IC reliability. This IC reliability, basically, I've given an IC, and without knowing the internal circuit, and I can study the reliability for the IC itself, and so to calculate what would be the lifetime. And first of all, I calculate the failure mechanism, and then I derive the equation for the failure mechanism, how it changes with time. And by using a particle filter method, I'm able to shorten the time for the reliability test and get accurate result. Alright, so the last thing that, one of the things that I want to discuss is, that this is the battery model that I mentioned earlier on. So what I've done is that by just looking at the discharge current, I'm able to develop the model, the circuit equivalent model, based on electrochemistry. So this equivalent circuit model, each component represents different components inside the battery. So with one discharge curve, I will able to determine all these component value, and this component value will allow us to determine what will be the maximum charge they can store in the battery at this point. Because the maximum charge they can store will actually decreases after many charge and discharge cycle. And so this is a method which is very fundamental based on electrochemistry, and we can work for all the battery. And when we do this, we actually are able to, once we get this equivalent model, we are able to evaluate what will be the impedance. What will be the impedance of this battery. So with this impedance, that we are down here, you can see that the blue point represents the experimental result of the EIS, and whereas the red one is calculated from our model. you can see how good is a match. So this is the first time where we can go from link the time domain with the frequency domain, and from there we can able to detect the health of the battery stuff. Okay, let's go to this one. So as you can see here, I actually cover this center here, cover a very wide range. And that's the reason why I call this center as a one-stop solution. Because I cover from the material, from the layout, from the device itself, from the battery to the system. And just now you see the wind turbine. And I also do another two work. One is to look at the aircraft generator. How do we when to replace the aircraft generator timely, and also instead of replacing the entire generator, I find out the root cause, which is due to the bearing, so I only change the bearing and in a timely way. I also perform a system reliability study on the plasma machine that's used commonly in the wafer fab, because in the wafer fab plasma etching process is very common. And they need to ensure that the chamber are not contaminated. That's why generally they use what we call the particle per wafer pass. But this is not very effective. So what I've done is that by using statistics and the data, I'm able to develop when they're supposed to clean their chamber, so that there will be no unexpected contamination. Alright, so with this, these are the few work that I've done. There are actually more. And so what I want to introduce is that with this work here, I generate quite a number of patents, and also some of the work is being awarded the best paper in the international conferences, and also with a different grant from the industry as well as from the government as well. Okay, the last thing what I like to share with everyone is that over the year of 30 over years of in reliability, I trained many students in a different area on the reliability for metal interconnect, nanotech, quality reliability engineering, and power semiconductor devices. So these are my students that graduated from me, and presently they are all, mostly they are in the MMC. For example, this one is in the ST Micro, and some of them are in Intel or in SMIC, and they are in Intel, and in Global Foundry, and so in NSP, and so majority of them are actually really is in the MMC company or being a university professor. Okay, so I hope that this will be a brief introduction of the center itself. Later on, I will introduce what are the equipment that we use and that we have in this center. And then later on I will share the various work in more detail to everyone exactly what I have done in the publication. Thank you.
This is Keithley 42000 semiconductor characterization equipment, and this machine helps us to characterize the devices like BJT, NPN or PNP, MOSFETs, two-terminal resistors, capacitors, and the diodes. So basically with this device we can do the frequency sweep analysis, DC sweep analysis, or AC analysis for the devices to find out their performance with respect to different characterization schemes. So this device is very helpful to find out the characteristics of various devices which we are using inside the circuitry or to design the systems. It consists of basically 4 SMUs that are used for measuring purpose of the characteristics of the devices. So this is a very powerful device for any characterization of the devices, starting from the, let's say, for the very low level DC measurements to the ultra fast IV pulse and transient measurement of the devices. So this is our Cascade Microtech 1164 reliability test system, which is used for electromigration testing and TDDB testing as well as the HTOL testing. So this system is a 4-pack system. That means we can we have 4 slots of DUT boards which can be tested at a time using this system. So we are having these 2 interfaces along here. One is the user interface and the one is the TCU. So user interface is we are having a software. So with the software we can control the whole system for testing purpose of electromigration or TDDB, and TCU is used to control the oven, which is having this since for the electromigration or STOL we need a high temperature as well, environment as well. So for that will be controlled with the help of TCU. So by using this complete system we can do the testing of wafer level as well as the package level ICs. So we have two source meters for different measurement purpose. The one is 2461 source meter. This source meter can provide us a voltage range from 0 to 100 volt, and the current is from 0 to 10 ampere. So this can be used for measurement purpose. It has means two channels. We can do the measurement is the online as offline as well. For the offline we have four inputs at the front panels: force high, sense high, and sense low and force low. Using this we can create a Kelvin 4 probe method to measure the resistance of a DUT. And we can also, from the back panel, we have on LAN connection through which we can control with this system for the online measurement using the software provided by the Keithley. Along with this source meter, we also have a high power source meter 2651A, which can provide us a maximum current of 550 ampere and the maximum voltage of 40 volt, and the resolution is 100 femtoampere per 100 nanovolt, and the power rating for the 2651 source meter is 2000 watt. That source meter can also be used as a offline and also for the online mode. For the online mode, again we need to connect that source meter using a LAN connection and the software provided by the Keithley. We have a TFG3210E arbitrary function generator that includes 32 predefined waveforms, AM, FM modulation, sweeping and TTL output. The maximum frequency that can be obtained with this function generator is 10 megahertz. It is having a 3.5 inch TFT LCD display, and it has a 40 sets of panels for setting, saving and recall the datas, as well as the 32 standard or built-in waveforms and 8 set of user defined waveforms in the channel B. So this function generator can be used for testing different DUTs under standard waveforms as well as the built-in user defined waveforms that can be created using this function generator. So we are having different types of DC power supplies. So one, we are having a single channel power supply whose number is ABM PS9610A. This is 60 volt and 6 ampere 150 watt power supply. And also we are having a ABM 9360D dual channel power supply, which is 30 volt power supply. And we also are having a very high voltage DC power supply 2260B 8001. This power supply range is 0 to 100 volt that can be used for testing the high power devices such as the high power diodes or the transistors for the testing purpose. So we are having these different power supplies for testing the devices. This is our MDO 3104 mixed signal oscilloscope. The analog bandwidth of this oscilloscope is 1 GHz. Sampling rate is 5 GS per second, and it can record the wavelength up to 10 megapoints. It is having a 4 analog channels and a spectrum analyzer up to 3 GHz.
This is 30 centimeter integrating sphere from Mentor Graphics. The model is Terra LED. It measures optical characteristics such as color coordinates, Skoptic flux, radiant efficiency, luminous efficacy, radiant efficacy, and correlated color temperature for LEDs and solid state lighting arrays. The range for voltage is 0 to 5 volt and the current is 5 milliamp to 2 amp. It implements JEDEC standards such as GESD 5151 and 5152 compliant LED test setups. The temperature dependence of the light output parameters can be captured as the machine provides a temperature controlled environment during the measurements. Thank you. Okay, this is smart, flexible and yet powerful SCM from Jewel company. The model number is JSM IP200. The maximum acceleration voltage of this machine is 20 kilovolts and the magnification is 300,000x. It is an easy to use SCM with specimen exchange function called NAVI. This function guides user for sample handling. It has another important function called Zero Mag for seamless transition from optical to SA imaging. Now for the elemental analysis, we have a special function called Live Analysis, which can provide real-time display of elemental composition for the sample. Okay. Another important function is Smile View Lab for the seamless report generation for the results.
We have hot circular exit oven and time oven in our center, and this oven can go up to 300 degrees C and with the accuracy of 0 plus minus 0.1 degrees C. The hot air is circulated inside the oven to maintain the temperature of the chamber. This oven is coated with galvanized steel powder from outside and within stainless steel plate from inside. It also has independent over temperature protector for self-diagnosis function. This is T machine weather simulation tester. The model number is TMJ9707S. The light source in this one is of 4000 watt that covers the whole solar light spectrum. The irradiation intensity in this chamber can go up to around 1400 watt per meter square, and the chamber temperature ranges from minus 45 degrees C to 125 degrees C, and the humidity type range is from 20% to around 98% relative humidity RH. This machine is designed to test and perform an accelerated test in order to check the reliability of the product. This is xenon arc weather chamber. The model number is TMJ9707. This xenon arc weather chamber is designed to test a wide range of materials in the fields of coating industries, automobile industries, construction industries, communications, textile industries, aviation, rubber and plastic industries and etc. in an accelerated test to find out the impact of sunbeam ray or wavelength equivalent to sunlight for the light proof and discoloration of material. The features of these machines are: it uses a xenon arc 6500 watt light source, and the wavelength range that it covers is from 300 to 800 nanometer. It can go up to different irradiation intensities also, such as from only at 340 nanometer, only at 420 nanometer, and it also covers the range from 300 to 400 nanometer as well as from 300 nanometer to 800 nanometer. The chamber temperature range can go up to 95 degrees C and the minimum is 10 degrees C. And the humidity range that it can maintain inside the chamber is 20% RH to 98% RH. This is frequency vibration machine and the model number is VS50V. This is an electrodynamic vibration test system and this results in the rotating force, pulse and vibration force generated from mechanical operation or earthquake. Usually vibration phenomena take place in the operation of ship, aircraft, road vehicle, propeller and spacecraft. This tester can simulate such vibration by setting wave of vibration duration and other parameters according to their testing requirement. With this machine, we can perform different international standards such as IEC, ISTA, military standards, ASTM, EIA, JIS, SAE and CNS standards.
This is a battery cycle tester from Biologic with model number BCS815. It is incorporated with BT Lab software, which provides proper control on experiment and also advanced analysis on experimental data. Some of its applications are high quality electrochemical impedance spectroscopy with a range of 10 kHz to 10 MHz full scan. It has a 18-bit analog to digital converter with 40 microvolt resolution. It is suitable for high precision colorimetry with as low as 6.3 ppm. The voltage range is 0 to 9 volt with a 2 millisecond grab time. This is a temperature and humidity controller from King Design with model number KD162FUL. We use it for acceleration test to check product reliability. The temperature range is minus 70 degrees Celsius to 190 degrees Celsius. It has a cooling capacity from 85 degrees Celsius to minus 40 degrees Celsius in 20 minutes and a heating capacity of 24 degrees Celsius to 190 degrees Celsius in 30 minutes. The relative humidity range is 20% to 98%. It has two modes, fixed mode and a programmable mode. In the programmable mode, we can change the input parameters of temperature and humidity with specific time. This is a Fourier transform infrared microscope from Thermoscientific with model number IM10 Nicolet. So it is used for microspectroscopy and material identification. It has two modes, room temperature and a cool mode for a higher accuracy. It has basic and advanced data processing program customization. It is incorporated with thermoscientific Omnic Picta software for reliable results and Nicolet IN10MX microscope for better speed and sensitivity of single point measurement and good quality chemical imaging. This is a digital microscope from Keyence with model number VHX5000. It has a higher resolution and large depth of field with working distance of 6.5 mm to 25.5 mm. We can view images from 20 to 2500 times magnification. Measurements like radius, diameter of samples can also be performed with precision. With the help of 3D display function, true shape of an object can be understood fully, and also with the help of split screen function, comparative analysis of two different samples can be performed.
Okay, so this is a drop tester machine from company King Designs Industrial Corporation, and the model number is KD128A. Okay, so the drop tester is applied to test the anti-vibration covering protection capability of packaging material or product's impact resisting capability to determine the improvement parts of related packaging design, materials and structure. It can also contribute to promote the packaging material and product strength. For this particular machine, the testing height is can range from 300 to 1800 mm, and the maximum load which we can use is 80 kg. Okay, so this is a thermal characterization machine, belongs to Mentor Graphics company, and the model is T3star. Now T3star is an advanced transient thermal tester for thermal characterization of IC packages, power semiconductors, LEDs and systems to evaluate thermal characteristics rapidly. This is a solution consisting of proprietary software and hardware. T3star serves requirements in the semiconductor, transportation, consumer electronics, military and LED lighting industries. T3star is applied to understand package thermal metrics and structure, calibration of thermal simulation models, reliability and quality assessment. It gives an insight into the product's internal structure and heat flow. It can provide a detailed information about the structure function, whether it's differential or cumulative, and the outputs can be obtained in the form of measured unit, thermal response, thermal impedance, thermal time constant spectrum, complex locus and thermal resistance. Okay, so this is a confocal scanning acoustic microscope, also known as CSAM in general. It's from the company PVA Tepla, and the model number is SAM301. Now CSAM uses ultrasound waves to detect changes in acoustic impedance in integrated ICs and other similar materials. It can be used for the analysis of samples in the ultrasound frequency range up to 400 MHz. It is designed by default for a transducer. It is equipped with a graphical user interface for ease of operation and flexible applicability. Now the sample bath and the scanner can be adapted to custom requirements. The scanning range is 320 mm cross 320 mm. It is also equipped with 1 giga sample ADC with an optional 2.5 giga and 5 giga. Now the smallest pixel size which can be obtained from this machine is 0.5 micrometer. Okay, so this is a decapsulation system from company Teltech Semiconductor Pacific Limited. The model is Jet H Pro. This system uses acidic corrosion of molding compounds to expose dye in any kind of IC package. It's very useful for LEDs or the solar cells. Now the flexible etch time this system provides is 1 to 1800 seconds. It has a 100 etch recipe storage. It also includes a wide temperature range for the anti-corrosion, and the range is 20 degrees C to 250 degrees C. It has a 13 mixed acid ratios. It also had wide range of etchant acid volumes. It also provides wide range of user selectable acid mix ratios. It has an ability to perform multi-step decapsulation processes. It also includes pulse etching, which enables rapid decapping with minimum acid consumption. It also provides optimization of acid carrying capacity to maximize vortex etching. So this is a multi-probe system from CL Technologies Company Limited. The model number is MultiView 4000. It is a multiple probe AFM for advanced experiments such as nanoscale transport, optical pump probe and read-write experiments. The Raman excitation source is 457 nanometer laser with 50 milliwatt power. It can also be extended to different wavelengths of laser. It has a highly sensitive Raman spectrograph with 4 gratings and high sensitivity cooled CCD detector. The spectral range is 200 to 1050 nanometers. It supports a variety of standard AFM and SPM imaging modes. The SPM functions include AFM, electrostatic force microscopy, magnetic force microscopy, and thermal conductivity microscopy. It also has an advanced multipass techniques, a software for combined AFM Raman imaging, a digital camera for sample observation, and a long working distance with 50x objective.
This is a P384 series portable thermal analysis system. This is used for thermal image analysis. The major specifications are region emissivity correction, automatically calculate the total area of emissivity, enlarged and rotated by 90 degree, can be stored and analyzed, multi-point temperature display and annotations, zone temperature profile, dynamic later sectional temperature profile, heat automatic analysis and other analysis, 3D temperature trends and area resistance analysis. This is a high-speed calculation server. The model number is Dell PowerEdge T630. The major function of the server is to do high-speed calculations for complex softwares like ANSYS, Weibull and WASP, etc. Major specifications of the server are: it has DDR4 memory with 256 GB of RAM, 32 cores, and Intel Xenon processor E52600. It has 7 input-output slots and it has RAID controller as well.
So this is Auto 3-axis load tester from the company SE Test Systems. The model number is 9505 SF. It can be used for all kind of compression tests, auto multi-point testings for regular products. It can also be used to perform automatic stroke test and value storage. We can perform multiple stress tests for the products. This system can also determine stress during the stress as well as the relaxation process. The system also allows us to perform a lifetime stress test by running the load conditions over the object for multiple times automatically. The speed range is 1 to 200 mm per meter. The weight capacity is 170 kg and the servo motor can move in 3 axes. This is a reflection polariscope from Vishay Micro Measurements. The model number is LFZ2. It can be used for the instant identification of stress concentration and zero stressed areas. It can also be used for the quantitative measurement of stress and strain at any point on the structure. It can be used for stress analysis over a range of points or an area of the structure. It can also be used for varying stress load effect. The range of elongation by using various coating types is 0 to 150%, and the system can provide a 10 microsecond resolution for 3 mm coating thickness. This is a glove box with gas purification system from Skylab Vigor. It allows a person to work with hazardous substances such as radioactive materials or infectious disease agents, and the second allows manipulation of substances that must be contained within a very high purity inert atmosphere such as argon or nitrogen using transparent window. It has an extra high capacity gas purifier with 60 liter capacity. It has a circulation blower from company Fuji. It has 7-inch color touch panel. with a large and small antechambers. It has a software controlled quick purge system, energy save mode, and a purity of less than 1 ppm oxygen and hydrogen.